Alright, so let's dig in. Let's see, we have vectors A, B, and C placed on a circular grid. The rings reveal each vector's magnitude. A and C point to the 10th ring. You count up these little rings. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. So vector A goes all the way up to 10. Vector C also goes all the way out to 10. So they have a magnitude of 10. In this case, the magnitude just means the length of this vector, which is 10. B points to the 8th ring. 1, 2, 3, 4, 5, 6, 7, 8. So vector B has a magnitude of 8. Here are vectors A, B, and C placed on a grid. Direction is described by the angle in degrees a vector makes with the positive x direction. Okay, so we're always starting from our positive x direction, just like in math class, right? We start in the positive x, and then we count our degrees anti-clockwise until we get all the way to 360. Positive directions are above the x-axis, negative directions are below the x-axis. Vector A has a direction of about 53 degrees. We can see it's not quite at 60, and it's definitely more than 45. Vector B has a direction of negative 150. Vector C has a direction of positive 135. A negative degree. That's kind of weird, right? Just remember anything beyond 180 is down in the negative world. Here are vectors A, B, and C placed on a rectangular grid like you're used to in algebra class. So it's the same vectors, just rather than being on that crazy circle thing, it's just on the regular coordinate system, where we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We can't easily see what each vector's magnitude or direction is. However, we can easily see how far right or left the vector points and how far up or down the vector points. These two numbers are called the vector's components. Components just means pieces. So everything is made up of these components, or all of these vectors are made up of these components. Vector A, for example, moves to the right, and then it moves up. Vector C moves to the left, and then it moves up. Vector B, left and then down. Vector A points 6 right and 8 up, so vector A's components are positive 6, positive 8. Positive x, positive y, we're going to land in that first quadrant. Vector B points 7 left and 4 down, so vector B's components are negative 7, negative 4, negative x, negative y, third quadrant. Vector C points 7 left and 7 up, so vector C's components are negative 7, negative x, positive y gives us the second quadrant. So the same vector can be expressed either as magnitude and direction or as components. This is an example of how vector A would be expressed as both. So we start off with the magnitude at positive 53 degrees. So magnitude at 53 degrees. Magnitude at direction. The component form is positive 6 in the x and then positive 8 in the y. There's vector B, same format, and vector C. We need a way to change a vector from its magnitude at direction form to its components, because it's not always going to be useful to use the magnitude at direction. Instead, we may need just one little piece. Maybe we only need a horizontal component, or maybe we only need the vertical component. But we're given the full vector. So how can we do that? So we have the a sub x to show this is the x component, the horizontal component. And we have the a sub y to show that's the vertical component. So if you think of the entire world as being, for right now, 2 dimensions, but you can also throw in a third dimension here. We have the x dimension, we have the y, and then we have this way, forward and back. That's the z. So it's x, y, z are the 3 dimensions that we live in. We're only going to deal with 2. If we needed to deal with 3 though, it's not a big deal. You can handle it. As long as you can handle 2 dimensions, you can handle 3 dimensions. Magnitude of vector A is labeled A without the arrow overhead. The direction of vector A is called theta sub A, where theta is the Greek letter theta, which is used to represent angles. If we have more than one angle, we'll move on to alpha or maybe phi, but for the most part, we're just going to use the Greek letter theta. The components of vector A are given subscripts a sub x for the horizontal and a sub y for the vertical. The components always make a right triangle with the vector itself. And that's great news because we love right triangles. They're easy. There's a lot we can do with them. It's great. The components are the legs of the triangle. So we have the first leg here, and then we have the second leg here, and this is the angle that we make. Remember, we start counting our degrees from the positive x-axis. So if we imagine a coordinate system overlaying this image, this would be 0, positive x-axis. We would start counting our degrees from this ground or flat surface. The vector itself is the long side of the triangle. It's called the hypotenuse. The horizontal component for this specific triangle is the adjacent component. Notice it's adjacent to the angle. What that means, what adjacent means is just touching. So if the side of the triangle is touching the angle, that's your adjacent. The other one that's far away from the angle is going to be your opposite. Because a sub x is on the adjacent side of the triangle, we can use cosine. Well, how do we know to use cosine? Hold on, I'll come back and we'll talk about that.